All right, sorry about that. We'll go ahead and kick it off, I think. Thanks all for coming. I'm Jonathan Keller. I'm the product lead for Unity Catalog and Databricks SQL here at Databricks. Excited to continue the conversation from the keynotes where we talk about how to build the best data warehouse on the Lakehouse. I'm joined today by Haley Creech from GSK, who's going to talk about their experiences and success doing data warehousing on Databricks. And then also Franco Patano's here, and he's going to talk about the best practices and tips and tricks from the field and how to get you started on building a data warehouse with Databricks. Standard disclaimers apply. So why do we say the best data warehouse is a lakehouse? And the honesty, it starts with a strong foundation that enables all your data, analytics, and AI in one place with a single governance model that allows you to move from descriptive analytics to predictive analytics very easily with a single copy of the data. World-class performance at a fraction of the cost is layered on top of that, and then ease of use for both analysts and administrators, and then of course integration with a robust ecosystem is how we end up delivering the best data warehouse on a lakehouse. So let's dig into this a little bit and talk about the various layers. Starting at the bottom of the stack is the open and reliable data lake foundation and centralized governance. I can't emphasize enough how different Databricks is and how unique and valuable this is for customers. In a previous role, I used to lead one of the major cloud data warehouses, and I can tell you our customers struggled constantly with this. They ended up having multiple copies of the data, and some even employed entire teams of people to arbitrage cost across the cloud storage or the specialized storage of some of the other data warehouses. It's expensive, time-consuming, difficult to run AI and data warehousing the same, and it just doesn't work very well in the end. So Databricks is different in the sense that we built entirely on a single source of truth for your data, and that is the Delta Lake format. Delta Lake is an open source format built on top of Parquet, but it adds capabilities needed for data warehousing, like ACID transactions, time travel, performance advancements, many of the things you saw today, things like the vectorized sort and window functions, that all end up giving you data warehousing capabilities, reliability, and performance. Databricks SQL processes data using Delta Lake, which allows it to provide the structured approach for ingesting, storing, and auto-optimizing data that needs reliability, quality, and performance. As we announced earlier today, now with Delta Lake 2.0, all of this functionality is also open sourced as well. And so you get the full parity and power of the Delta Lake system, both in open source clients and of course with Databricks as well. Unity Catalog. If you're not familiar with our journey on Unity Catalog, we're excited to announce the GA of Unity. And this is our centralized governance and security layer for the Lakehouse. What it does is it gives you a global view of all of your users, groups, and data, and allows you to really set up this define data once, secure it once, and use it anywhere model, whether that's use it across multiple personas or use it with fine-grained governance within the data warehousing functionality itself. Along with that view of this global view of data comes the functionality like search, discovery, and browse of the data to make it simpler to find and to develop data at scale. And it also enables Delta sharing, which is our secure sharing mechanism that enables things like the marketplace and the data clean rooms, which were announced earlier today. One of my favorite capabilities with this is the data lineage capabilities. And we didn't stop with like tables and columns with data lineage. We extended it to notebooks, workflows, dashboards, and we extended it across all the languages, SQL, Python, Scala, R. So of course, this solves like the simple governance scenarios like who accessed my PII data? Did anyone make a copy of sensitive revenue data? It answers all those questions very easily, but it also gets into data quality and data observability. You can look at a dashboard and know, hey, the CEO's dashboard, probably not good today because it depends on these tables, and these tables are built by these jobs, and those jobs didn't run last night. So if you start thinking about the use cases of lineage, it's going to be a really powerful addition to the data warehouse on the Lakehouse. Moving up to real-world performance, Delta Lake itself provides pretty impressive performance capabilities native to the storage layer in the file system, but we didn't stop there. We're adding serverless SQL compute, which helps us scale and provide great performance and auto-scaling across the system. And we also added the Photon engine. So with serverless compute, Databricks Serverless removes the need for manage, configure, and scale cloud infrastructure on the Lakehouse, freeing up your data team to do what they do best. You get instant elastic SQL, serverless compute decoupled from storage, and benefit from the performance optimizations of the entire stack and leveraging the serverless compute. Databricks automatically determines the instance types and automatically scales up or scales down. So from a cost management perspective, you can incur no cost, scale up to the maximum that you need or that you'll allow, and then automatically scale back down to 0. This allows you to get really great TCO, up to 12x better TCO than some of the data warehouses we've seen. And it really allows you to manage that cost and provide high concurrency and low latency at any scale. So we're excited to have serverless compute now in preview, and you'll see much more on this in the future. Paired with that serverless compute is the Photon engine. This is not your grandparents' Spark, as they like to say. It's like this is the new next generation query engine that we've used it to process exabytes of data, but it really provides this massively parallel engine in native code based on the vectorized CPU's functions. Incredibly high performance, enables capabilities like Bloom filter joins and things like that that are coming soon. This is how we delivered those great performance benchmarks that you saw earlier in the keynote, really heavily dependent on the Photon engine, and we're excited about what it's done. 3x to 8x faster on a lot of interactive workloads, and this is only what we've gotten so far. We've got the sort, the windowing functions, and things like that still coming, and so it's going to get faster and better over time, and it's a really big TCO savings so far. So moving up the stack, as you think about data warehousing, most companies have a handful of data scientists or data engineers, but they have hundreds, if not thousands, of people that author SQL. So as you move up to that large number of users, interacting with Databricks SQL and doing data warehousing on the platform, ease of use becomes critical, both for the analyst experience and the admin experience, because the admin experience of tuning and managing the cost and the infrastructure becomes more important as well at that scale of user base. So for the analyst experience, Databricks SQL offers a full-featured SQL editor that allows analysts to write queries in familiar syntax and easily explore schemas. Analysts can ingest data directly from the cloud storage or local files with simple SQL syntax, or they can leverage Partner Connect, which is our tooling for connecting to sources like Fivetran for managing ingestion at scale. Regular SQL code can be saved in snippets for quick reuse, and query results can be cached. And additionally, query updates can be scheduled and automatically refreshed as well, as even issuing alerts and things like that when code changes or data changes, so that you can really have this great end-to-end experience for your tens, hundreds, or thousands of analysts interacting with Databricks SQL. On the admin side, Databricks SQL also gives you full visibility into query execution with in-depth breakdown of operational levels. This allows you to understand performance and characteristics of specific queries, but more importantly, it allows you to manage the cost and the scale and the performance of your overall system. So if you're an admin of Databricks SQL, you can really get to choose and make those trade-offs in terms of performance versus cost for individual users or individual workloads, so that you can be in control of the cost and the performance for all of your customers. Tying it off is the seamless integration with the ecosystem, of course, because it's not all within Databricks. And so tying off of this, we've really worked hard to make sure there's a great experience both in ingesting, transforming, and querying data. So whether you're ingesting data and working with data no matter where it lives, you can use tools like Fivetran or others to pull in the data from Salesforce, SAP, Google Analytics, wherever you may need. We have the tight integration across that to make it really easy to manage and move data into Databricks. Transformation, we partner closely with tools like dbt or the familiar tools of choice for transforming the data, in addition to the ability to use Databricks jobs and ELT natively. And then on the consumption side, you can query from any tool, whether it's Power BI, Tableau, Looker, MicroStrategy. Obviously, there's a broad support for the BI ecosystem. But we're also continuing to expose APIs that make it possible for you to build your own applications. And we're happy to announce the Go, Node.js, and REST API availability now, so you can build your own applications, or you can leverage the existing ecosystem to get the best out of Databricks SQL. Pivoting a little bit, we're actually it's important to understand, we're both pivoting the best of lakes and the best of warehouses into the lakehouse with a ton of advanced SQL capabilities and additional data engineering capabilities, and making it really fluid across these different personas. So we're democratizing ML with Python UDFs. This is not a bolt-on Python solution like some of the other cloud data warehouses. This is the same core engine running something we call Safe Spark, which provides great isolation of Spark and allows you to have really amazing performance as you switch back and forth between SQL and Python. And these UDF capabilities are in preview now. You can also orchestrate DB-SQL queries and alerts and tasks with workflows. And so you can have jobs that leverage SQL or SQL that leverages jobs to really author your ELT transforms in the way that's best for your organization. And then we're bringing some traditional SQL data warehousing capabilities into the mix too, with materialized views and things like primary and foreign key constraints. So net, the Lakehouse vision is really both the best performance, the best capabilities, and the best of lakes and the best of data warehouses all in the Lakehouse. Don't necessarily take my use case, my word for it though. Many of our customers are actively using Databricks SQL and running their data warehousing on the platform. Many are just allowing access for BI tools so you can have a single source of truth of data and everyone accessing that data. Others are simply empowering everyone in the organization to query data. But the net is there's a rich and growing ecosystem of customers using Databricks SQL to run their data warehousing. And with that, we're actually going to drill into one. Pleased to welcome Haley from GSK, and she's going to talk about her experience with Databricks SQL.
Thanks so much, Jonathan. I'm so happy to be with all of you here today in person. So at GSK, we treat and prevent disease with our vaccines, specialty medicines, and general medicines. We focus on the science of the immune system, human genetics, and advanced technologies in 4 core therapeutic areas to have major impact of health at scale. We're ambitious for patients, we're accountable for impact, and we do the right thing because 2.5 billion people around the world count on us to get it right. So it's important to note that the advanced analytics journey at GSK did not start with the enterprise data and analytics platform. There are some amazing data experts all around the company. We have folks in vaccines developing end-to-end in the vaccine space, machine learning algorithms. In commercial, they're developing insights for the commercial line of business. In the supply chain, they're optimizing the manufacturing chains and the supply chains to decrease cost. And each one of these groups, if you dive into these, they're even more siloed, which it's great that they're creating insights. But as I mentioned, there's silos. There's opportunity for data redundancy. And most importantly, from my perspective, there's this amazing story to tell about a treatment going from the research and development phase through the supply chain actually getting manufactured all the way to commercial and being sold to customers. And with these different groups operating in silos, that story gets lost. Additionally, there are inconsistent governance patterns. Chargeback is different between groups. They may not be using the right tools for the problem. And all of this together inspired the enterprise data and analytics platform at GSK, which is called Code Orange. We have a fit-for-purpose ingestion tool catalog. We have an enterprise data lake that is a harmonized mesh architecture, which we'll be getting into shortly, that has a complex and audit-ready security model. We have core and common data tools that are easy for different customers to use for things like data modeling, data cataloging, and data preparation. And we also have analytics suites for advanced and traditional data and analytics with things like, in the future, data science workbenches and analytics workbenches as well. So how did we do this? We built Code Orange, as I mentioned, the brand name for our data platform, on a harmonized mesh ecosystem where we see the respective business units before as different nodes. I really scaled down this image so I wasn't overloading you with each component on the node, but it is much more robust than this, and I'm totally willing to discuss this with you guys after the session if you have some more questions. As you guys can see, we leverage Databricks on the mesh core, which is where our common services are, and then on each node as well as our ADLS Gen 2 storage, which provides a lake on each business unit's node or business functions node. Note that we have connections, both networking and virtualization between each of the nodes to enable that data sharing, which I'm going to get into that a bit more as we get to the end of this session. During this talk, though, because of the scope of this session, I really want to focus on how we're leveraging Databricks SQL. Additionally, it's important to note that we're also using Databricks as a key component in our fit-for-purpose ingestion catalog and as part of our data analytics workbench and all of those tools. Focusing on Databricks SQL, I really want to focus on 3 key problems that it solved for us as we released it to the supply chain business unit last quarter. The first one is the ease of use. I know this may seem silly to some of you, especially in startups or smaller organizations, but in a 90,000 person company, it is so difficult to download software. Some people don't have the right permissions to download any query type tools that they need from the internet, and they have to go through a complex governance process just to be able to hit download. But since this is browser-based, it really increases time to insight by making it accessible to anyone who already has the right access. Additionally, our super users who are using Databricks as part of that fit-for-purpose catalog or as part of our analytics suite have everything they need in one place. So they can easily go back and forth between their Python notebooks and then query whatever they just transformed and make sure it looks accurate using these query capabilities, which is really easy to use for those power users. Next, I want to talk about cost. So this is not Databricks. The screenshot is actually of Cloud Health, which is how we do FinOps at GSK. We have saved a lot of money by using Databricks. In the first iteration of the platform, one of our major spend was actually on traditional data warehouses, because as you guys know, they're always running, always incurring cost. And one thing that Databricks SQL did for my customers is it put financial power into their hands as a user of the platform. They're able to optimize when the queries run. They can make it so it's basically an on-demand system that they can actually control, rather than something that's just always incurring cost. And finally, connectivity. I know this is going to be mentioned a lot earlier today and a lot more, but there are many, many, many different ways to connect to downstream analytics tools. Just by going to Power BI, for instance, you can click a couple buttons and you can figure out 20 different ways to connect from ADLS to a visualization tool. But whenever you get into complex security models, some of these ways just don't work. And in a big organization, this leads to lots of support tickets, customer complaints, and similar problems. Databricks provides that easy connection to the downstream applications for traditional reporting insights. And most importantly to me, as someone who ends up writing a lot of documentation for the customers, it's self-documenting. People can read and understand how to do it without any jumping through hoops. What we used to do before this was an option, we used personal access tokens from the data science and engineering workspace, and we have some pretty complex documentation in place to allow them to connect to Power BI using personal access tokens. And so this is a game changer, as was demoed in a supply chain demo at the end of Q2 last year. So my customers are demoing this to their customers because it's so powerful. So I want to take a second to look at the future. As we all heard, Unity Catalog is becoming GA in a couple weeks, which is so exciting to me. And let me tell you why. Looking at the architecture diagram from before, we see that each of these nodes are connected. Well, also notice that we have workspaces in each environment as well. So each of these different business functions have an analytics and ETL workspace per environment, but what happens whenever you're trying to access data in each one? Today, we have two options. One, the customer, so the person in the business, has to open up, let's say, the supply chains workspace, but then also the enterprise's workspace, and actually not see their data in a unified view. We also have another approach where we use service principals, but what that does is it triggers a secondary governance process. So whenever someone has already been granted access to the data, because this isn't user-based, it's still another process of them having to go through and jump through hoops to get access to that data. What Unity Catalog is going to do for us is it will allow in a single workspace the customers to have access to all of the data they have access to. And it will actually allow that sharing experience to greatly improve across the company. Whenever I started talking to you all today, I mentioned the story of the treatment all throughout the process and how it touches every single business function to get that global view of what it means to bring a treatment to market. And with Unity Catalog, I think that we're really going to be able to accomplish this. Thank you all for the time. Next up, I would like to introduce Franco, who's going to be going through some best practices with you all.
Thanks, Haley. So I really liked that the very first benefit was an answer to a very long-standing problem with technologists. Works on my computer. With web-based, that is something we don't have to worry about anymore. All right, so what are we going to be talking about today? I've got some pro tips from the field. If you don't know me, my name is Franco Patano. I was a solutions architect in the field for about 3 years. I recently became the product specialist for Databricks SQL. So I help customers figure out what this lakehouse thing and how their warehouse patterns fit into that. First thing I want to talk to you about today is why these cloud data warehouses are not a real modern data platform. What do I mean by that? Well, data warehousing was great. It was created over the past 30, 40 years to solve a very, very real problem. The business couldn't use files. Source systems were dumping files, or they had databases. To get that data from those systems into hands of business users. Reports was the original use case, the OG use case for data. And essentially, they thought, hey, if we just process this data overnight in batch fashion, and we create a common data model, that we can build all the reports off that, and you can integrate all your applications. It's going to be great. Warehousing is essentially rules. It's rules around how do you manage that data. A warehouse is not really a technology stack, as we know by all of the vendors that offer warehouses. What we find is that it is significantly more expensive to do ELT in a cloud data warehouse. I don't know about many of you, but you bought tools like Informatica, SSIS, Ab Initio, I could go on, to save you the cost of premium warehouse compute. Why in the cloud you have warehouse vendors telling you just shove all of your data into a warehouse? I don't know. When 20 years ago, we were trying to see how we could stem the bleeding of the premium warehouse compute. It's actually very, very, very complex to do ELT in a cloud data warehouse because you have to shove stuff into something they call variant, which means I don't really want to, we don't know what this is, we're just going to put it in here. It leads to a lot of complex data management protocols that you have to deal with. They say that there's streams. There's this marketing material says that you could do streaming in a warehouse, but really it's just a much faster batching protocol than they had before. It's not a real streaming protocol. And try to put unstructured data. One of my favorite questions to one of my favorite data architects that I talked to like 10 years ago was, hey, how do I put audio files into a warehouse? And they were like, that's easy. You put it out on storage, and then you create a link to it. And I was like, well, that's not putting the data into the warehouse. I'm creating a reference to it. Because warehouses can't really take unstructured data. Maybe they have support for a variant type that you can shove something into and then deal with it later, but it's not really supported. Now, when you want to go and access all this data, you have to pay that premium warehouse compute every time you want to touch the data because it's all locked up in their locked up proprietary formats with pessimistic concurrency. They say that you can do data engineering on a warehouse, but let's get serious here. You didn't do data engineering in a warehouse. Yeah, we created programmatic extensions to SQL like PL SQL and T-SQL so that you can do programmatic things in a warehouse, but that doesn't mean it's optimized for it. They added the functionality, and then they wanted you to do it. Quite often than not, if you want to do anything besides reports and dashboards, you're going to have to take that data that's locked up in the proprietary warehouse, you're going to have to get it out onto the data lake or some other storage format to bring it into the advanced analytics or AI ML tool, and then what are you going to do with the data that's just been produced there? Now you got to copy it back. And it ends up having all of these lots of copies, and your costs just explode. Because not only do you have to pay for this premium warehouse compute, now you have to maintain this entire ecosystem around this, this cloud data warehouse that they told you was a modern data platform. So what is modern data warehouse at Databricks? Essentially, we have real streaming. I don't know if you heard, we're about to make streaming light speed at Databricks. It's quite amazing. So we are doing real streaming. This isn't something that's being marketed as streaming. This is real low latency streams. I think I saw 100 milliseconds up there that we're targeting. It sounds to me like a real streaming protocol. You could do real CDC type workloads on including partners or manually. You can build this all out using Databricks and using Delta Lake as the underlying structure. Essentially, in warehousing, we called it raw staging presentation layer. Nowadays, in the lakes, we call it bronze, silver, gold. Call it what you want to call it. But basically, we drop all our raw data here, and raw data is going into data lake storage. Data lake storage is awesome. It's cheap, it's abundant. The clouds basically give it away. Dump all your data there, and then refine it inside the data lake using cheap commodity storage that Databricks has. And essentially, you create the staging or the silver layer and that gold presentation layer. And now, all of your use cases can be served on one set of the data, one version of the truth. You don't have to create copies. And you can service the machine learning and AI use cases, and you can service those reports and dashboard use cases out of our SQL warehouse. What do customers normally do with these medallion zones, or how does this stuff work? It's very similar to raw staging presentation layer. Essentially, in the raw layer, you want it to be a replica to your source. Customers ask me all the time, what does that mean? What am I supposed to do with bronze? It's your files. If a vendor is sending you files, they're dropping on the data lake, that's bronze. If you're getting a stream, land the data in a tabular format, that's bronze. It's basically whatever you're getting from your source, because you want provenance to what you got. Then you clean the data up. You essentially create normalized forms, but don't over-normalize. People ask me all the time, well, should it be second normal form, third normal form? It shouldn't be over-normalized. I mean, about 2 or 3 is about where you should be. That's where we see the best price performance. And essentially, you want to organize it around key domains, and you want to create mastered, clean data for your analysts to use, for your analysts and scientists to use. You want to create cross-reference data so that they can link different systems together and derive better insights. And you want to create data enrichment in the silver layer. Then you want to create a presentation layer for your solutions, your point solutions, essentially your star schema for your BI tools to read. These are all read-optimized objects that are really good for traditional warehousing workloads where you would serve from. And I'm talking about dimensional modeling. Dimensional modeling, born out of the warehouse technology, but that doesn't mean you can only do them in proprietary formats and with pessimistic concurrency. Delta Lake is an open format with optimistic concurrency, and to me, as a person who's been practicing for a while, it's really flexible to deal with. You can create dimensional models. Like I said, don't over-normalize your models. Can you build whatever you want to build? I like to say, it's a long-running joke, it's Databricks, you can build whatever you want. It's also Databricks, you can build whatever you want. But essentially what we advise is you use conformed dimensions like you would in data warehousing. You create surrogate keys, you can create identity columns in Databricks now. And you can still create slowly changing dimensions. So if you need SCD type 2, it's great support for that. And you've heard that materializers are coming to allow you that really fast, scalable layer. If you want to build semantic layers, or if you want to build really, really fast read objects, you can do that now. So what are the steps to success if you want to build dimensional models? You want to use Delta Lake. You've heard all of the investment that Databricks has been making to Delta. We've just open sourced it. It's probably going to be the new standard to do data warehousing on a data lake, and so much more, because it can do everything a data lake can do and everything else. And leverage Databricks SQL. You've heard how awesome it was. I agree. It's my favorite product at Databricks. But use it for query serving. You can even use it for ELT if you still want to do ELT. But if you haven't heard of Delta Live Tables or DLT, I think DLT is the best spot to do ETL. Auto-tuning. There's a parameter inside of Delta. We've talked about it. Before it's released to everybody, there's traditional Databricks is hidden behind a parameter. Just tune file sizes for rewrites on and forget it. It's one of the greatest configs that exists. Just turn it on and forget about it. Your performance will be great out of the box. You want to optimize your Delta tables for fast data skipping. You heard in the keynote from Michael, there's a lot of good stuff that went into optimize, but also Z-order. Dimensional models are multidimensional. I don't know if you heard Michael talk about it, but Z-order is a multidimensional curve. It works great for dimensional models. Actually, when we practice in the field and we just put a Z-order on a fact table's join keys, we see performance go from hundreds of seconds to single-digit seconds. All you have to do is a Z-order. But then you also want to analyze the table. It's just a simple command, analyze table. And this collects queries, the table statistics for the optimizer. So if you're a DBA, you just have to issue these commands, and you're kind of setting yourself up for success, just like your typical admin jobs you have to do in a warehouse. So when we're looking at the data lakehouse, some people have asked, well, how does data mesh work with Lakehouse? Is it different? Is it the same? You're going to hear from the creator of data mesh at the keynote, and we believe it's similar concepts. Essentially, you can build meshy architectures with Lakehouse, because you're going to want to land all that source data in Bronze. And then in Silver, you're going to create domains, your product domains, your customer domains, all of these different domains where all of that data, it goes so that it gets cleaned up and ready for consumption. Then from there, you build point solutions, specific derived data products from that data. And this is where mesh comes into play, because you essentially make the data available, you democratize it, and then you allow your analyst users, your scientist users to use whatever data you have at their disposal to deliver value to the business. And this is how we see data lakehouse mesh architectures in practice. But that's not all. That's architecting it. How do I govern meshy architectures on Lakehouse? It's very similar to how it's done in warehousing. Essentially, you heard about Unity and all of the new, the way that the compliance is going to be created on with Unity is with SQL grants or ANSI SQL grants. It works the same way. So essentially, you would create stores, databases, catalogs, views, schemas, however you want to architect it. You would grant different levels of users or groups different levels of security so that everyone can read from your enterprise data sources, but they can't modify that data. They can't delete that data. The departments can have their own data sets. So if they want to build their own data sets that they've stewarded and managed, they can build their own and make that available, but only they can read and write that data. Only users can only read that data. Same thing with user-level databases. These are lovingly called sandboxes, or however you want to refer to them, but users can bring their own data, and now they can cross-reference to all the other data. And this is how you can have a mesh-type architecture on Lakehouse. So you've heard about these new SQL warehouses. There's really two knobs that you have to tune, and I want to tell you a little bit about how you can use them. Essentially, if you're using a BI or warehousing use case, I traditionally advise to start with a medium. It has really good out-of-the-box, kind of middle-of-the-road choices for the cloud instance types, and it has that, what I consider that good point to start at. It's not too small and it's not too big. It's kind of like that Goldilocks position. If you need lower latency, or if you have larger data, if you have more complex queries, if you have like computation that's happening live with functions, you increase the size of the warehouse. So you go medium, large, extra large if you like. Now, if you need to support more concurrency, you would scale out the warehouse. You could start with min. I advise starting with min equals 1, max equals 10. And essentially, as you can see here on the graph, Databricks SQL is looking out for your costs behind the scenes. Just like you saw in Haley's talk where their costs went down, this is what's happening behind the scenes. We have logic. I can't call it AI yet. Product won't let me call it AI. But it's an algorithm that basically determines the cost of all the queries that are queued up. And it only boots the right amount of compute to handle the user's needs. So it's always looking out for your user's performance and your budget at the end of the day, booting whatever resources it needs to handle the demand, and then shutting them down so that you're not paying for idle. And I'm here to tell you that the best warehouse is a lakehouse. And we normally always show the TPC DS benchmarks, but I'm going to tell you as a warehouse person, I've had other warehouse people come to me and be like, yeah, that's great. That's one half of the puzzle. TPC DS is query serving. That's like the front end. It's with the users. And honestly, users complain about performance, and that's where a lot of us spend our time because that's what's directly applicable. The other side is ETL. How do I take these files, these CSVs, text files, fixed width files, XML files, JSON files, all these files, how do I take that and put it into the warehouse? That's like the biggest piece of the puzzle that's missing from all these benchmarks. And I actually went out into all of the benchmarks that TPC offers, and I was like, well, which one is representative of a warehouse build? And there's this old 30-year-old benchmark that has no submissions called TPCDI. And, and when I first started doing this, I got laughed at because everyone was like, no one does this. This isn't a thing. Like, it's kind of just been sitting there. Turns out Reynold, who's our chief architect, went to school with one of the guys that wrote the paper, and he introduced me. And we have a team at Databricks that started working on this. It's called TPCDI. It's a quintessential warehouse ETL benchmark. It takes files and turns it into a data model. And I'm here to tell you that we haven't actually submitted an official submission yet. Like TPCDS, there are some rules we have to change. So in order for us to do an official submission on TPCDS, there's this weird rule that you have to pull out a hard disk on the server to prove you're redundant, and it can kind of solve for a critical failure. It turns out you can't go into S3 in the cloud and just pull a disk out. So it's not the same thing. So we have to work with them in order to submit it. But what I want to tell you all today is we've run the benchmark on Databricks. We finally got it to work on Databricks using Delta. And if you want to hear more about this, you check out my other talk, So Fresh and So Clean, Real-Time Data Warehouses on the Lakehouse. It's at 4 o'clock today. We did 22 million rows per second processed. That's pretty amazing. And in one of our, like we were tuning this thing, Shannon, my colleague who's been performance tuning this thing for a week to really squeeze everything he could out of it, we got 1 billion rows processed. Biggest scale factors you can generate is about 1 terabyte of files. 1 terabyte, 970 gigs of CSV text files, and we ETL'd it into the dimensional model for $1. It's actually 97 cents. It's pretty amazing. So I'm here to tell you that the full picture of the story, the reason why the best warehouse is a lakehouse, is not only did we rock and win the world record on query serving, but your costs are going to be more than efficient and scalable when you want to ETL all of those files and streams into the warehouse structure. All right, why do customers choose Lakehouse? You've heard it a lot of times. I'm just going to sum it up for you so you understand. Reduce copies of data. Warehousing causes you to copy into the warehouse. You have to copy into and you have to copy out of in order to use that data. Delta, you can read that data straight away on the lake. It's your data, does not require Databricks compute. So it reduces your copies of data. Because Databricks offers a complete lakehouse platform out of one provider, it actually reduces the overlap of your vendor sprawl, and it reduces your redundancy in the cloud, which equals better cost efficiency. And finally, because it's one unified platform, it simplifies your path to production. So we remove the friction of taking that great, awesome idea that has tons of potential and actually putting it to where you can get that return on investment. And if you want to migrate to Lakehouse, we have a tremendous amount of resources to help you. We have a technical migration approach where we analyze your architecture and infrastructure, and we have a way to migrate your data, migrate your ETL and pipelines, and then finally connect all of your BI and analytics to your new modern data stack in the cloud. And then you can open up all those use cases for data science and ML. We also have a wealth of partners that are helping our customers accelerate their migrations if they don't want to do it all themselves. And you should definitely check some of them out. A lot of these partners are here today in our expo hall. And you can talk to them to figure out how to help you with your migrations. Please, if you found this stuff interesting, I have a bunch of other colleagues that have other amazing talks that are deep diving into a lot of different areas. I'm going to plug my talk, So Fresh and So Clean again. But I also have, we have talks on data mesh, deep dives given by our other colleagues. And there's a list of other talks here I think that you should check out. And then finally, if you do have questions, I don't know if we're going to have time to answer questions here, but in the expo hall, there's going to be a lot of people in the Databricks booth wearing clothes like this little shirt here with the nice little Databricks logo. You can ask us any questions that you have if we didn't get to them today. So please, if you have any questions, come check us out in the expo hall. We have a bunch of field engineers and technical people that would love to answer your questions. And we want to help you build your lakehouse.